Okay, so today we are going to study formal charge. Formal charge. So what is formal charge? There is a formula for calculating the formal charge. Formal charge is equals to valence electrons minus half bonding electrons minus non-bonding electrons. Okay, so VE is valence electrons, number of valence electrons, and BE is bonding electrons, number of bonding electrons, and NBE is the number of non-bonding electrons. So using this formula we will find the formal charge on each atom in the Lewis structure. Actually one molecule can have more than one Lewis structure, so we have to decide which Lewis structure is most likely. So in order to decide that, we use this formula to calculate the formal charge on each atom in the Lewis structure. And based on the 3 points we decide which Lewis structure is most likely. So the first point is the formal charge on each atom should be minimum. On each atom in the Lewis structure should be minimum or zero. Minimum or zero. If it is zero, it's good. Second, the difference in the formal charge between the central atom and the peripheral atom should be minimum or zero. Difference in formal charge between central atom and peripheral atom should be zero, or we can say minimum. And the last point is that if there is a formal charge on any atom, then the negative charge should go to the most electronegative atom. So we say if there is a formal charge appearing on any atom, then negative formal charge should be on most electronegative atom. So based on these 3 rules we will decide which Lewis structure is going to be most likely structure. So let us take an example of azide ion, N3 negative. This is an azide ion, AZIDE, azide ion. So we will draw the 2 Lewis structure for this molecule, and then we will decide which Lewis structure is most likely. So in order to draw the Lewis structure, we will find the total valence electrons. So total valence electrons for this molecule is 3 times 5 and plus 1, 16 valence electrons. We halve them to get the number of pairs. So 16 by 2 is 8 pairs. Okay, so since we have 3 nitrogen atom, so we just consider one nitrogen as a central atom and the other 2 nitrogen as their peripheral atom. Then we start counting the pairs. 1, 2, 3, 4, 5, 6, 7, 8. So all the 8 pairs have been put on this molecule. Now we will check the octets of the peripheral atom and the central atom. So peripheral atom has 8 electrons, 1, 2, 3, 4, 5, 6, 7 and 8. So we have completed the octet of the peripheral atoms. 1 2 3 4 5 6 7 8. How about the octet of the central atom? Central atom has only 4 electrons, so we need 4 more electrons to complete its octet. So what we do, we transfer the electron. So we get this structure, N double bond N, and now the 2 lone pairs on nitrogen, and this nitrogen still have the 3 lone pairs. Now we again check the octet of the central atom. We find that we have only 6 electrons, 1 2 3 4 5 and 6 bonding electrons only. So we need how many electrons? We need 2 more electrons. So what we can do, we have 2 options. Either we can transfer the electron from this nitrogen, or we can transfer the electron from this nitrogen. So we will get 2 Lewis structures. Okay, so let us see that if we transfer from this side, so we will get this Lewis structure, N triple bond N. Now we will have only 1 lone pair left, and here we have 3 lone pairs. Now we see the octet of the central atom is already complete. Now what is the last thing? Last thing, we will find the valence electrons of the central atom. So nitrogen has 5 valence electrons. So let us trace it. 1 2 3 4. Where is the fifth one? Fifth one can be this side, or fifth one can be this side. In order to find this, let us first trace the valence electrons of the peripheral atom. So nitrogen has 5. 1 2 3 4 5. Wow, so we have one extra electron. So this extra electron is coming because we added one extra electron in the azide ion, right? So this is that extra, and we have one more bonding electron. So this electron belongs to this central nitrogen, because nitrogen has 5 valence electron. So we say that we have a dative bond from central to the peripheral atom. Let us now trace the valence electron of the left nitrogen. 5 1 2 3 4 and 5. Yeah, perfect. So this is our Lewis structure, one of the Lewis structure. So let me draw it nicely here. N triple bond N, and there is a lone pair here, and we have a dative bond here, and we have 3 lone pairs here. Actually the negative charge is on this nitrogen, because of that extra electron. So now we will make the negative charge here on the whole molecule. So this is my one of the Lewis structure. I say that this is my A structure. Now in this molecule, as I told you, that we can also proceed like this. Means that this nitrogen can also give the electrons like this. So if it go in this way, then we will have this type of structure here, N double bond N, and the 2 lone pairs on this nitrogen, and we have double bond and this and this. Okay, yeah. Let us trace the valence electron of the central atom. 1 2 3 4. Where is the fifth one? Okay, so in order to trace the fifth one, let us first find the valence of the peripherals. 1 2 3 4 5. Okay, so it means the fifth electron of the central atom is hiding here, this one. So it means there is a dative bond here. Now let us find the valence electron of the other nitrogen. 1 2 3 4 5. Okay, so we have one extra electron here. So that extra electron is because we added one extra electron because of the negative charge. Okay, so this is our Lewis structure, and we have one dative bond. So let me draw it nicely. So my Lewis structure now is N double bond N double bond N, and there are 2 lone pairs here, and there are 2 lone pairs here, and there is a dative bond between this and this. Okay, and this is my another Lewis structure. I name is at B. So out of A and B, two Lewis structures, we have to decide which Lewis structure is most likely. So in order to find that, what we have to do, we have to find the formal charges on each atom in this structure. So let us see the formal charges on each atom on structure A. So my structure A is N, triple bond N, and we have one lone pair here, and we have three lone pairs here, and like this and like this. So let us find the formal charge. I say this nitrogen is A nitrogen, B nitrogen, and C nitrogen. So the formal charge on nitrogen A is valence electron of nitrogen 5 minus half bonding electrons. So how many bonding electrons are there? So nitrogen A forms 3 bonds and one bond has 2 electrons. So we have 6 bonding electrons minus non-bonding. Non-bonding is this lone pair. So we have 2 electrons. So this is 3 and this comes out to be 0. Now what is the formal charge on nitrogen B? So valence electron minus half bonding electrons. So how many bonds do the central nitrogen is forming? 1 2 3 4, 4 bonds. So each bond is 2 electrons, so we have 8 electrons. Minus non-bonding is not there, so this becomes 1. Now what is the formal charge on nitrogen C? Valence electron minus half bonding electrons. So how many bonds this nitrogen C is making? 1 bond. So each bond has 2 electrons, so we have 2 total. Minus how many valence electrons? Non-bonding electrons. Non-bonding electrons are 6. 1. So it comes out to be minus 2. Okay. So now we find the formal charge on our structure B. What is structure B? Structure B is this. So we have N bond, this one, 2 lone pairs, and double bond N, and 2 lone pairs, and we have a negative charge like this. Yes. So now we will find the formal charge on, let us say this nitrogen is A, this is B, this is C. So the formal charge on nitrogen A, valence electrons minus half bonding electrons. So how many bonds nitrogen A is forming? 2 bonds. So we have total 4 electrons minus non-bonding 4. So it comes out to be 2, 4, 5, 6 and minus 1. Now formal charge on nitrogen B, valence electron minus half bonding electrons. So central nitrogen is forming 4 bonds, so we have 8 electrons minus there is no non-bonding electron, so this is 1. Formal charge on nitrogen C, valence electrons minus half bonding electrons. So nitrogen C is forming 2 bonds, so we have 4 electrons minus non-bonding 4 electrons. So this comes out to be minus 1. Okay, so what we see that the difference in formal charges. So we see here in this case, structure A, the formal charge on this one NC is very high, minus 2. It's very far from 0. So obviously this is not following the first step. So what was the first step? That the formal charge on each atom should be minimum or 0. But here we see we have a lot of formal charge. So this is not obeying the first rule. Second thing, we see the difference between the formal charges of central and peripheral atom is how much the difference. If I find the difference, so the difference comes out to be 1 minus minus 2, that is 3. Wow, so high the difference. You can also think like this. Suppose this is a line and this is 1 and this is 0, this is minus 1 and this is minus 2. So we have here formal charge for NC and we have formal charge on central atom 1. So how much difference? So the difference is 3. Wow, so high the difference. So the difference is very high. Let us see what is the difference between central atom in this case and its peripheral atom, central and peripheral. Let us see the difference. So the difference in formal charge, we have 1 minus 1 is only 2, right? We can consider like this. This is my 1 plus 1, 0, minus 1, minus 2. So the central atom has a formal charge of plus 1 and peripheral NC has a formal charge of this one. Okay, so we see that this is only 2 difference. So this difference is very less compared to this from atom Lewis structure A, and also the formal charges are very less compared to that one Lewis structure A. See, minus 1 only and minus 1 only, but here we have 2, so high. So the most likely structure is this structure, structure B. Structure B is my most likely structure. So this is how we decide on the basis of formal charge which Lewis structure is most likely structure.